Hey, science enthusiasts, welcome back. It's always a pleasure to have you here as we explore the fascinating world of physics together. Today, I'm diving into one of the most fundamental concepts in physics, Newton's first law of motion. This law is the cornerstone of classical mechanics and helps us understand the behavior of objects in our everyday lives. Ever wondered why objects stay still or keep moving until something interferes? This question has intrigued scientists and curious minds for centuries. Let's break it down. Understanding this concept can change the way you see the world around you. Newton's first law, also known as the law of inertia, states an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction unless acted upon by an external force. This simple yet profound statement explains a lot about the natural world. Sounds simple, right? But it's incredibly powerful and explains so much about how our universe works. From the motion of planets to the way we move in our daily lives, inertia is everywhere. Imagine you have a soccer ball on a flat field. As long as no one kicks it, it stays there. This is a perfect example of an object at rest. That's the inertia of the ball, its resistance to change, and its state of motion. Inertia is a property of matter that resists changes in motion. Now, if you give it a good kick, it starts moving. The force applied to the ball changes its state from rest to motion. But why does it eventually stop? This is where the concept of external forces comes into play. Things like friction with the ground and air resistance. These forces act against the motion of the ball, gradually slowing it down until it stops. Inertia isn't just about objects staying put, it also explains why objects in motion stay in motion. It's also why a spaceship in the vacuum of space keeps cruising along once its engines are turned off. In the absence of external forces, the spaceship will continue moving indefinitely. With no air resistance or friction, there's nothing to slow it down or change its direction. This is a perfect demonstration of Newton's first law in action. Cool, right? The vastness of space provides a unique environment to observe the principles of inertia. But let's bring it back to Earth. Our daily experiences are filled with examples of inertia. Have you ever been in a car that suddenly stops? This common experience is a great way to understand inertia. You feel that jolt forward. That's your body's inertia at work. Your body wants to keep moving forward while the car stops suddenly. Seatbelts are crucial because they provide the external force needed to counteract that inertia and keep you safe. They hold you in place, preventing you from continuing to move forward. So why does inertia matter? Understanding this fundamental principle has practical applications in many fields. Understanding it helps engineers design better vehicles, lets us predict the motion of planets, and even enhances sports strategies. Engineers use the principles of inertia to create safer and more efficient designs. It's everywhere, from the smallest particles to the largest galaxies. Inertia plays a role in the behavior of all matter in the universe. Knowing about inertia gives us insight into the natural order of the universe. It helps us understand the fundamental laws that govern motion. Next time you're playing sports, driving, or even just sitting still, remember, Newton's first law is at play. This law is constantly at work, shaping the motion of everything around us. It's the reason behind the motion, or lack thereof, of everything around us. From the way we move to the way objects interact, inertia is a key player, and that's pretty amazing. The more we understand about inertia, the more we can appreciate the complexity and beauty of the physical world.